Thank you very much, Don. Can you hear me right here? Yeah? Okay, all right. Thank you. When Raza asked me to give a seminar on my research, I said, I don't think I want to bore you guys all again one more time, I think, after so many years with what I do for research, but I could leave the research that I do in the context of this large initiative that I'm sort of working with right now. So it's a real pleasure and an honor here, I think, to be standing in front of you today and talk about this thing that's been taking up quite a bit of my time, as Don said. But it's a wonderful initiative, actually, and I think we really, I think as UBC being its home, I think I'm very proud of UBC for taking the lead and doing its sort of, I would say, part of a global citizenry, I think, and work with India, and I think create this kind of wonderful linkages with a country that's on the move. And I want to talk to you about really what we're doing as part of the center now, which is so, in fact, far-reaching and certainly very satisfying for myself. So I'm going to talk a little bit about India. I don't know how many of you have been to India, but I'll give you a glimpse of India as to how complex and how exciting and how wonderful and how beautiful and how colorful India is, actually. So let me show you a little bit about India. Then I talk about how ICIMPACTS came about. ICIMPACTS is this Canada India Research Center of Excellence, which is the first international NCE. Now, I don't know how many of you are familiar with the NCE program, but the NCE program was created about 17 years ago. Don't correct me if I'm wrong about that, but about 17 years ago, the government came together to actually provide large chunks of funds, actually, to solve very large problems. You know, in the old days, our research, funding was fairly fragmented. We were giving small bits of money to researchers to actually do some work, but we were not solving problems. So NCE model was very interesting because it said, well, we'll solve large problems by giving large sums of money to interdisciplinary groups, which means that you combine mechanical engineering with civil, with medicine, with water, with everybody else around. You combine it with social sciences, humanities, and you can actually do wonderful things together to solve a problem. So this NCE model is an extremely important model, actually, and in fact, it's been now emulated around the world. In fact, US has launched a Network of Centers of Excellence program. Japan has launched a Network of Centers of Excellence program, which is completely modeled on our Network of Centers of Excellence program, which is actually great. But this one that I'm going to describe today is the first international Network of Centers of Excellence, which means now we are going outside of the country and creating linkages with the world as such. And in this particular case, it's India. And I'll tell you exactly how this thing came about. This is the very first one, so I think, in fact, I'm very pleased that it happens to be India in that particular sense, my motherland. Then I'll talk a little bit about the research, how it all sort of came about to be. There was a stiff competition. I'll explain to you how it actually happened. I'll talk a little bit about our partners in this wonderful endeavor. And then at the end, I will, of course, thanking you for support over the years, and also I'll have an invitation to participate. There is an open call for proposals right now, so if you're thinking about, in fact, working with the center, you're definitely certainly open to that kind of endeavors. So, all about ICIMPACTS. We just had a wonderful launch about a year ago, and you recognize some of the people there. On the extreme left is our new president, Arvind Gupta. You can see the presidents of the three universities there. I think there are Samara Sekra that you will recognize on the left photograph there, who's a part of the center. Stephen Teep you can see as well, actually, as well as from the University of Toronto. And on the right side are our counterparts from Civil, and I'm sure you've seen these pictures. We're all part of this wonderful endeavor together. This is at the launch. India. Now let me introduce India to you, which is in fact, the people who have been there, of course, will understand how complex India is, but really, the ones that have not been India, it's a 5,000-year-old ancient civilization, 325 languages. We have problem with 2 here, by the way. 1652 dialects. I think when there's more than 2, the problem goes away, I have a feeling. 18 official languages, 29 states and 5 union territories, very large square kilometers of land, 7,000 some kilometers of coastline. You can imagine what kind of issues that sort of brings in. 1.3 billion population, very close to China right now. 5,600 dailies. I don't know how many of you have actually read the book Argumentative Indian by Amartya Sen. This is a country full of dailies. These people read newspapers. And it's a it's part of the culture actually to be aware of what's actually going on. 15,000 weeklies and 20,000 periodicals. So it's an amazing country in terms of its just sort of dissemination efforts. It has a GDP of 1.84 trillion, slightly higher than that of Canada, but of course the population is very large as well. And it's growing at an average rate of 8%, which means that really this is the country which has got tremendous prospects right now. It's a parliamentary form of government, world's largest democracy, I'm sure you know that, and world's fourth largest economy right now. So it's a huge sort of, in fact, engagement with India that we have right now. The world-class recognition of IT, biotechnology, and space. Just in Bangalore alone, there are 10,000 biotech companies right now. Just imagine the prospects this country has at the moment. Largest English-speaking nation in the world, third largest standing army force, over 1.5 million strong. It's a huge army, of course. We have some very friendly neighbors. And the second largest pool of scientists and engineers in the world. So it's a complex, yet beautiful country, and it's amazing. Max Muller, when he visited India, he said, well, after visiting India, I started believing in God. And I think this is the kind of country we're dealing with here, actually. A land of breathtaking beauty. I think, on the left side is Mount Kailash. On the right is, of course, our old railways. The bottom there is Rajasthan. If you ever want a camel ride, that's the place to go for. And on the bottom right is the Ganges. And I'll describe to you that we have a wonderful project of cleaning up the river, because this, as you know, this 2,800 kilometers river is actually very polluted, and ICIMPACTS has actually been invited to work with them, in order to clean the river. Now, we go there all often, but it's not all fun. It's not all work.
Freudian slip.
Sorry about that. So you'll see up there, in fact, our Vice President John Hepburn there, Vice President Research, and we sort of went on a tiger safari. And I want to show you a little movie that we shot here. So here's a movie that I will tell you. And I think the end of this movie is in fact quite scary, because you will realize how close this tiger is to us. So it's a little, right there is our Jeep, by the way. So I'm so glad to be back. Now about India. It's a land of IT innovation, as you know, and we start them young. We absolutely do. And on the other hand, in fact, that's the first version of iPod, by the way. That's where, I'm pretty sure that's where, Steve Jobs got the idea once he visited Bangalore. He said, wait, that's a great idea. We can miniaturize this thing. And I don't know how many of you have actually heard the term Bangalore. Bangalore is a word in Oxford Dictionary now. And Bangalore means that your job was transported out of the country. And it's exactly what's happening in terms of really all these IT positions now. Now, men and women get along in this country. It's a women's special bus full of men. Most of the time. So, the creation of ICIMPACTS, actually, this was in the 2011 budget that the government announced that there would be $15 million to create a Canada-India Research Center of Excellence. The competition was given to the Network of Centers of Excellence Directorate in Ottawa. There were 18 proposals submitted, and fortunately, ICIMPACTS proposal that we submitted from UBC, along with the University of Alberta and Toronto, was the winner. And the competition was extremely stiff. As I can say, there were 18 proposals submitted in different areas. Aerospace was one of them, food security was one of them, there was on mobile health from McGill. So there were a number of proposals submitted, but fortunately the proposal that we submitted was the winner of this entire competition. and Stephen Harper in 2011, also 2012 November when he went there, and I think we went with him, he announced the center, and you can see our illustrious Prime Minister of India there, PM Manmohan Singh. And this was really a wonderful start, I think, that he was the one to announce the center, and it really made us very proud that it had the support from the Prime Minister's office to announce this very large initiative. So that's the one I'm going to talk about today, is the center, how we actually created this, what does the center actually do, and where are the opportunities to participate. Now it has got 4 pillars. And each one of the pillars I'll describe. One is research and development. Like any other network of centers of excellence, research is the backbone. And because it's initiated by the university, research is, of course, at the backbone of everything that we do. So collaborative research. This is not research for the sake of writing papers. This is not the research which actually leads to increasing your H index. This is collaborative research in certain focus areas. And it's tailored to community needs. I think so. This is the research that we are doing to needs of the community, both here and in India, which means, and I'll also define a community with you, it's really the partner communities we have identified in India, which are small villages and small cities, and large cities in this case, which are our communities of focus. And all the work we're doing, those are the test beds, in fact, for applying some of these technologies that we're developing, the areas that I will describe. It's a multi-sector participation, which has got definitely academia, industry, government, and of course community. Community engagement is very important here. We have partner communities in both India and Canada, and I'll describe them in a second. And these are our partners for testing, adoption, and capacity building. So we're really looking at applying these technologies that we develop to these partner communities with industry involved and with NGOs involved. Now, industry involvement in trade pathways are very important. Now, the Canada-India trade, in spite of the fact that India is growing, in leaps and bounds, Canada-India trade is actually at a paltry $5.5 billion right now. United States does trade worth $320 billion with India right now. So Canadian trade actually is very, very small, unfortunately. And I think what we need to do is to expand this trade. And I think we are looking at, in fact, bringing industry from here in direct contact with industry in India, so that there could be, in fact, pathways for business, pathways for trade. So, of course, NC is not generally the one doing these things, but we think for this center, because it's an international center, we need to also promote business-to-business opportunities here. And, of course, there's the HQP and capacity building. Every time you actually have an NCE, at the backbone of it is creation of graduate students, creation of highly qualified personnel. And this program, we are targeting 700 students, researchers, and professional practitioners to be trained within the program itself. Now, on the funding side, Don already mentioned that we have 13.8 million from NCE, and then we have generated about 18.5 million from other sources. That includes universities, industry, NGOs, partner communities, etc. So our total budget is slightly more than 30 million right now. Now, the 13.8 was the easy part once the funding was allocated. It was the 18.5 million from the other sources, which includes Indian funding agencies, Indian government, Indian industry, Canadian industry, and our university. And I'm very thankful, in fact, to UBC, UFA, and UFG for providing sufficient support, I think, for the center, which is part of that $18.5 million funding. Now, on the HQP and training strategy, this is, as I said, our crux of what we're doing. It's next generation of innovators and entrepreneurs. So we are not only limited to training these students, we are also committed to making them entrepreneurs. If you want to grow trade, this trade can grow only when these students are provided entrepreneurial experience and entrepreneurial training. So these students will open up companies that will then work with India at a much higher tech level. Industrial capacity shortages, we're training people from the industry on both sides, particularly from India here. Curriculum development. As you know, India produces about 98,000 engineers a year. And if you look at, in fact, the number of engineers India is producing, definitely the quality is really not at par with what it should be. So these engineers are unfortunately unemployable. So we are also working with, in fact, the World Bank program right now to improve the quality of education there. So it is sort of weaved into what we are doing. Professional development and educators of the future. If you look at IITs today, in fact, about 30% of faculty positions at IITs are vacant right now because they cannot fulfill them. There are only 1,000 PhD that are produced in India every year. And so really there is a need, in fact, for capacity building in that country. If this country needs to move forward, it needs to actually train more PhDs. So let me just describe very briefly the research program. And if you're interested in more details, of course, you can go on the website and check exactly what the real projects have been funded and what we are actually doing in these 3 areas. So the areas that we are looking at are 3. The first one I'll describe is integrated water management. Now, water is a big problem in India, as it is in some of our rural communities and native communities here, the Aboriginal communities in Canada as well. So if you look at integrated water management, and if you just simply look at polluted water problem in India, it's absolutely mind-boggling. 37.7 million people in India are affected by waterborne diseases due to contaminated drinking water. More than half the sources of water in that country are contaminated. Natural sources, sewage, pesticides, fertilizers, you name it. Sadly, about 1.5 million children die each year from diarrhea, and that's completely, I think, can be eliminated. And water supply systems, this is where I think infrastructure comes into play. The transmission and distribution networks for both water and wastewater are old and severely deteriorated. So there is also an opportunity for civil, on the structural and material side, I think, to come up with these systems which are robust and more durable. So in the water quality side, which is led by University of Alberta and Dr. Mitra there, we're looking at 2 things. Water sensors, which actually can sense the quality of water and the load of pathogens in water and chemicals, and also water treatment. So I'll describe a little bit of the work that, of course, Pierre and Majid are doing in this case, and also Meena Hulfar and Dr. Roberts from UBCO. So they are all participating in this particular project in terms of water treatment. And sensing side, which is actually if you really have a handheld, simple sensor which can tell you what this specific E. coli content in the water is, etc., that can be very useful in terms of quick detection of what the quality of water is. On the research, on the health side, which is led by University of Toronto, it's in health and disease public health and disease prevention. It is particularly working on infectious diseases and especially water-associated or waterborne diseases. And if you look at public health, there are a number of underdiagnosed and untreated infectious diseases in India. Malaria, particularly if you look at dengue fever, 70% of India's population is at risk, which means if you look at the malaria map right now, it shows you really how big a problem malaria really is. There's a number of projects there that are actually looking at malaria and other infectious diseases as well. And I think it's also moving then into maternal health, which is a real problem in India, as you know. And I think it's applying those public health strategies to really understand how we can actually work with. So the 3 focus areas for our public health and disease prevention side is, first of all, development and evaluation of new technologies, particularly in infectious diseases and waterborne and water-related infections in both India and Canada. Walkerton is, of course, an example that comes to mind, and in fact there are issues even in Canada that we have in terms of contaminated water. And development, the focus area 2 is in development of mobile network health technology. So the cell phone use in India is absolutely one of the top in the world right now. And I think if you have such an intricate network of cell phone, one could actually use this for mobile health delivery, which means because some of these small villages do not even have a primary health center, the cell phone could also be a very good tool for actually getting advice. So you could actually feed in symptoms in there, you could feed in your temperature in there, which could all be fed into a system, could be looked at by a doctor in Delhi, and he can actually advise back through some system that this is what the diagnosis and this should what the cure be. So I think there is a great deal of, I think, I would say, prospects here, I think, for mobile health technologies. Application strategies, of course, to maternal and child health. So we're looking at also, in fact, applying some of these public health strategies to child care and maternal health. Finally, I want to describe a little bit about the work that we are doing. UBC is taking the lead in safe and sustainable infrastructure as part of the program. Now, infrastructure is a shared concern between these 2 countries. And if you look at, in fact, the bridge that collapsed in Quebec just in 2006, you'll notice that, and this particular bridge was inspected the same week it collapsed. What that means is, in fact, we do not have inspection techniques for these bridges which are good enough, in fact, to avoid some of these collapses that have taken place. 59% of Canada's infrastructure is more than 40 years old now. And if you look at statistics data, it will tell you that 37 years is in fact the expected lifespan from our structures today, and we designed them for 75 years. So there's a real problem, I think, in terms of infrastructure here as well. And if you look at just, in fact, coming from the Federation of Canadian Municipalities, which is telling you really what the deficit in this country is. We haven't spent time, effort, and thoughts on, in fact, maintaining our infrastructure in this country. And in fact, it's growing very, very rapidly. It's growing annually by 2 billion, our infrastructure deficit in this country, and it's in fact 6 to 10 times the level of all annual government infrastructure budget combined, which it means that you really have an issue, in fact, here as well, I think, in terms of infrastructure issues. So it's a common problem here. Now, India, I don't know how many of you have been to India, but India, if you look at the infrastructure, it's in a dismal state, absolutely in a dismal state. So Indian government, in its the 7th five-year plan, India plans its progress in terms of 5 year cycles. And in the 7th, I think it's the 7th plan right now, I think that we're looking at significant investment in infrastructure. And if they look at the infrastructure investment, it's very close to $1 trillion right now. So the Indian infrastructure budget is right now of the order of $1 trillion, which is, I think, a huge opportunity, in fact, in terms of building new infrastructure, maintaining new infrastructure, and some of the wonderful Canadian technologies can be very useful in that particular case. And again, there's a whole bunch of money going into housing, railway, airports, and things like those. So the focus area 1 for us, in fact, from point of view of UBC leading this infrastructure, sustainable infrastructure theme, is to actually develop green concrete and with low carbon footprint. Now, India, as I said, it's a growing country with tremendous demands in cement. So the total 2013 cement production in India was about 360 metric tons. It's only second in the world right now. India produces more cement right now than the United States. Of course, China beats everybody. China produces 10 times more cement than US does. But certainly India is the second largest producer of cement. And its total equivalent CO2 emission from Indian cement industry is about 325 metric tons, which is almost close to 32% of the entire industrial output, entire industrial greenhouse gas emissions. 1 ton of cement when produced creates 1 ton of carbon dioxide. So every ton of cement that we can actually produce less or use less of reduces our greenhouse gas emissions by 1 full ton. Now, on the other hand, India is also a power-hungry nation. If you look at, in fact, the Indian power, about 70% of Indian power is thermal right now. Of course, there's a little bit of hydro, a little bit of nuclear, but I think if you look at the entire power structure in India, it's generally thermal, like Alberta does here, actually. Our power is mostly hydro. So what power sector produces, this thermal power sector, is huge amounts of fly ash and huge amounts of bottom ash. So if you look at now the coal consumption in India, which is actually rising, in fact, as you might recall, there was a very large delegation here to purchase coal from Canada, because Canada is a net exporting country of coal, particularly thermal coal or coking coal. So our 2013 fly ash production in India was about 152 metric tons. Now that's a huge amount of fly ash being produced, and if you look at the bottom ash that's being produced, there's 40 million tons of bottom ash produced every year. If you look at the usage rate, only 55% of that fly ash goes into any particular use. 45% is actually landfilled. And out of the bottom ash, only 3% is used. The rest of it, 97%, is actually landfill. And in a country like India, I think this is something that can really be fixed. So some of the work we're doing here actually will take some of this fly ash and put it back into concrete, so you can not only reduce the amount of cement consumption, because fly ash can replace cement, but also at the same time you're sort of helping two industries, what we call industrial ecology, whereby you're taking waste from one industry and putting it into the other industry, so that you're reducing the overall global greenhouse gas emissions for the entire industry. So we are looking at, in fact, there's a huge bottom ash pit there, characterization and processing of waste materials. So we are not just looking at fly ash and bottom ash in terms of putting them back into concrete. We are also looking at rice husk ash. We are looking at recycled fibers, recycled aggregate, natural fibers, bagasse ash. India is the second largest producer of bagasse. So I think all of these materials can go into concrete to reduce the carbon footprint of concrete and reduce the amount of cement, which is wonderful, because if you really are reducing the carbon footprint of that country, we really need to progress in this particular form. Now, what do you do with these sustainable materials? If you look at now the structures in India, they are absolutely in a dismal state. And if you look at now number of major bridges, there's this typical bridge from Maharashtra, which is not too far from the city I grew up in, Nagpur. You got approximately 1 million bridges in India right now. And 1 million bridges in India, 40% of them are, quite a few of them are actually more than 40 years old, and there have been many failures. You see these failures all the time in India. Last year alone, there were 300 structural failures in one country. So you really have an issue, and I think if you have a bridge like that, of course, something needs to be done. On the railway network, on the other hand, which has got 125,000 bridges right now, huge need, I think, in terms of all of these bridges that require not just inspections, but also strengthening. And I think really there is a great opportunity, in fact, for us to get involved, and not just us, I think, in terms of research, but also Canadian industry to get involved in fixing these major problems in India. If you look at dams now, so India built a large number of dams right after its independence, about 190 large dams since independence, for hydroelectric power or for sort of inner dams which are for water for drinking and irrigation. And dam failures are very, very common in India, unfortunately. And we have similar problems here as well. I think our dams are also old. And if you look at roads now, I think India is producing huge amounts of highways. 20 kilometers of highway being put every day. You can imagine how large this actual project is in terms of producing highways in India. So the focus area 2 for us is the condition assessment and structural health monitoring, and some of the wonderful discussion that that Carlos had at the last presentation. I think it really follows nicely from condition assessment of these structures as to what their condition is and how we can do some structural health monitoring. So if you're looking at these failures, I think it tells you that in fact you really require to understand what the condition of these structures is before lives are lost. And as I told you, even that bridge that collapsed here in 2006, that was inspected the same week. What that tells you is that we really need good condition assessment on these structures to know exactly where the deterioration is and what's actually going on with these structures. That's the bridge I was talking about. And it's a stark reminder to us that I think we are also in this country don't really know what condition our bridges are in. Actually, and that really requires, I think, a fair bit of work, fair bit of research to apply these technologies. So what we're doing is we're doing non-destructive testing, so you can actually develop test procedures and test protocols which would actually tell you what the structure is doing, where the deterioration is, what the response of the structure is to a given load, and also put these sensors in terms of continuous health monitoring. So I'm showing some of the monitored bridges here. For example, the configuration bridge, which has got certain fiber optics and piezo-resistive sensors on it. There are a number of bridges in this city as well, which are being monitored at the moment with either regular sensors, fiber optic sensors, so we can understand really what these bridges are actually doing. The last focus area for the infrastructure theme is to develop strengthening technologies. So once you realize that the structure is deficient, what you need to do is to strengthen it, to understand, to make sure that its capacity back to normal. So we're doing, in fact, work on developing these strengthening technologies as loss of capacity, earthquake vulnerability, and conservation of heritage water infrastructure. So on the last bit, the heritage water infrastructure, we strengthening number of old dam structures in India right now, which are actually supplying water to some of these irrigation projects. So on the right side, you will see this Krishnaraj Sagar Dam in Mysore, which is in the south of India, and this is in fact a 110-year-old dam, which requires in fact tremendous amount of strengthening. And what you're looking at is some of the other available other projects for strengthening that are being conducted here. Seismic strengthening structures using smart FRPs, and certainly repair and strengthening against capacity loss or deterioration. So shotcreting, you can see some of the work that we've been doing in shotcreting in BC, and the nuclear reactor Janti in Quebec that I was involved in terms of FRP retrofits. So these are sort of the projects which are also now providing us with proper, I would say, know-how and database to actually go and repair some of the structures in India. So this is, there was an ISIS network that I was a part of. This was another NCE that looked at strengthening and health monitoring. And all that know-how that was created by the previous NCE now is becoming a wonderful inroads into repairing structures in India at the moment. Now you must wonder, if you have this large project, are these themes working in complete isolation with each other? You have the water theme, you have the health theme, and you have the infrastructure theme. No. I think what we are also looking at is theme integration. So the water theme actually, which looks at, in fact, water conduits and looks at water, water treatment and those kinds of things actually. So if you have a pathway to innovation, if you have a low carbon footprint material, as you're developing the systems, as you're applying them, it also helps, in fact, our water theme in terms of its water transportation systems. What that means is we're not just limiting it to one type of infrastructure, but we are also working with the water folks actually to develop infrastructures which actually can maintain purity of water is actually transported through our system. So this is a challenge. I know we are all sort of used to working, I think, in isolation, but once you start integrating with other fields, you have no idea how much I have learned about drug-resistant tuberculosis in the last 1 year, which I thought I'll never know. But you really require to actually understand what the other fields are doing as well, so that you can understand really where those sort of cross linkages and where the research sort of challenges are. Now, who are our partners? Of course, as I said, we have 19 academic partners right now, 8 government partnerships, 18 industry partnerships, and 15 community partnerships. This includes the Rotary Club, etc. These are the 3 universities that actually launched this: UBC, University of Alberta, and University of Toronto. Of course, UBC is the home for it, that's the host institution. But you have a whole bunch of other companies, other institutions, Indian Institutes of Technology. 6 of them are actually partnered with our institution. Number of companies you would probably recognize: Robonics, Tata, of course Golder, Reliance Industries, which is in fact one of the largest industries in India, or largest corporate entity in India, is also part of the center. And at the moment we are looking at a number of other partners which can now work with us, so that not only we sort of work together to solving problems, we also have an avenue of actually applying these solutions to both Indian environment as well as in the Canadian environment. And I think what's happening, which is in fact very good and something that we had not even thought about, is that some of these Indian companies are now starting to work with Canadian companies. So there was an Indian company that was here just about 2 months ago, and they were looking at actually some health monitoring projects here, which is wonderful, I think, because this has to be a two-way street, actually. This the same way I think Canadian companies are looking for projects in India, Indian companies are now coming back and saying, well, we need to grow this trade as well, actually, and start working with projects. And they have, in fact, expertise in certain areas. I mean, one area I would mention they have tremendous expertise is in heritage conservation. Now, India has been maintaining its structures for the last 2,000 years. I mean, the oldest structure we know of here in this country is the Parliament, which is more than 100 and some years old. So they have experience in actually maintaining heritage structures far more than we do. And I think this is a great opportunity for bringing some of that technology here. So it is really by no means a one-way track. I really see this as learning from both sides. And they have wonderful opportunities. We have wonderful opportunities to learn from Indian experiences as well, I think. And it's a great living laboratory for me. I think, it's just everything multiplies so many different so many times that you can learn tremendously by applying solutions to that context. I think, 1 million bridges. Can you imagine just the magnitude of the issue here? Now, I want to talk about our partner community. So apart from these industrial and other partners, we have identified some communities in India and Canada, and the Canadian side is still developing. We're slowly working towards that. But what we have in India right now is these areas that we have identified, or communities we have identified as our partners. So what we are doing is we are actually working with these partners, particularly with the mayor's office or with the public works there, to identify their issues in water, health, and infrastructure, and develop solutions which apply directly to that context, actually. And this is wonderful because this becomes a great test bed for technologies that we are developing to be applied in a partner community context. So, and I'll come to that in a second, but if you look at really just the way these communities have been identified, they have all first of all come on board. Roorkee, as you will recall, Carlos, that's zone 4 in earthquake activity. So again, they're looking for earthquake solutions actually, particularly. It's also a place where Ganges flows, the river flows. I think we're looking at, in fact, definitely water purification and water treatment projects, pulp and paper projects there along the banks of Ganges. Punjab actually, which is in fact a highly industrialized and a highly agricultural province or state, they have huge problems with pesticides contaminating water. They have problems with infrastructure. And finally, Nagpur, actually, where I was born and brought up, is a large metropolis of about 5 million people. They have huge issues in terms of just infrastructure, bridges, and things like those. And finally, we moved down to this tiny, small community called Tandebhavi in Karnataka. This is a community of 8,000 people, cute as ever. And we went there, actually, and it was great because they want a village road being built there. And I said, okay, that's a great idea. So we're building a kilometer-long village road, but this is a research project. So we are actually creating a village road with 5 different sections of experimental technologies. So we are putting in 5 new technologies in this 1 kilometer long roadway, which connects actually the town to the temple, which is wonderful. And they can't actually go to the temple when it's raining very heavy because monsoon actually blocks this road. So this road would be a kilometer long road, which would be a wonderful place. I think you can see the village there. And it'll be a great way to actually try some new technologies which we think are very promising, but in an actual Indian context. So 1 kilometer road, pavement that we would be creating there. In India, village road construction is a very large undertaking right now, and there is a Prime Minister's Council which is actually looking at this village road construction, Sadak Yojana it's called, and there's something like 100 and some thousand kilometers of village roads to be built there. And I think if we can come up with a technology which actually works very well in the context of village roads, I think there's a great opportunity here to move the technology to a much, much larger level and work with companies, in fact, in transmitting some of that information down to these small villages. But just I see the sort of just the sort of the opportunity here, I think, in terms of transferring some of our wonderful technologies, develop new technologies with Indian institutions, and actually apply that in this particular context. So just to give you some demonstration projects we have right now. So we have a project in Banthia Thermal Power Plant where we're looking at actually working on the bottom ash. They're producing 1,000 tons of bottom ash a day. And they're doing just landfilling it right now. So we're working on actually producing those. There's the bridge in Nagpur. We're looking at monitoring there, so we're starting to monitor that. And we just actually, we recognize our Premier Christy Clark there, that we just signed an agreement with this Vizag Steel to look at basically their water conservation and infrastructure. And then finally, this is the Tandebhavi Karnataka pavement project that I just described to you. So I think it's very, I would say it's very grounded in what we're doing on the ground basically, and apply these technologies, whatever comes from our research projects, into some of these wonderful projects. So here's your invitation to participate. We have an ongoing call right now. Please do take a look at really what we're doing as a center. You can participate in many different forms. You can certainly present or submit a proposal to work with us. There's a number of opportunities here. If you're a student, I think there are opportunities for exchange. We have funding set aside for exchange with Indian institutions. So I would say certainly take a look at our program. It's ICIMPACTS.com. Please go there and you will see really what those different programs are for training, for research, for industry. I think there's a number of programs in the industry, I think, in terms of joint workshops, joint seminars, and sort of training opportunities as well. I just wanted to thank, first of all, our beautiful people from UBC or Applied Science that are working with us. Susan Dunnington, Vijay, of course, and Pierre, Clarence, Carlos. Carlos, that's a very nice picture. And Majid, who's here. Is Majid still here? I think he's probably had to go a little bit. Oh, Majid is there as well. Majid, that's a beautiful picture too. So, and Meena Hurfar, Professor Roberts, and Humshin. So these are our applied science people collaborating with us, and I thank you all for your support for this particular endeavor. I know it's been a long way to get to this point, but everybody was patient with me, thank you, and when we were writing the proposal, and we succeeded. And at the same time, I also want to thank my own research group. I think, these are great people that I've worked with. You will recognize some of the faces here, and I'd also like to maybe introduce our new member of the group. Obina, where are you, Obina? As our new member of the group that has just joined, thank you for joining our group, and we really look forward to working with you. So thank you all. Appreciate your support over the years, and I'll be happy to take any questions.